Hi YouTubers, welcome to the channel. Today I'm going to be seeing if I can use a motor controller, a couple of PC fans which are supposedly silent, a few other bits and bobs. I'm going to see if I can make myself a cooling solution for here in the cave, get them mounted up, and let's see how it goes. Onward and upward, as they say. Welcome back everyone. Excuse me while I have my morning coffee. You see before you a plethora of AVR's program Arduinos. These are Arduinos. One is a clone. Well, they're both clones to be honest. So they're both a clone. That one is got a built-in Wi-Fi module, Arduino Mega. They're all clones, but they'll do the job. I'll come to why I've got them out soon. This is our motor driver. You can use this to drive stepper motors and or DC motors, which is what our fans are. So what we're going to do is we're going to program one of these using PWM. We'll probably just use a standard Arduino. We'll probably just go with a regular Arduino. I could use an Arduino Nano. Unfortunately, I don't have one to hand, which is rather annoying. The reason for these cables is something of note with each one of these Arduinos is you will see that they all have different programming ports. So we've got mini, so that's USB mini, USB micro, and standard USB. I'm not sure what the actual name is for that. There's probably a proper name. Can't remember what it is. Yeah, so that's something to be aware of. The actual kinds of cables you're going to need, make sure, because some micros, they've just actually got the power leads connected up, and so you can sit there for ages trying to figure out what the hell the problem is, and it's because they're actually a charging only cable, so be careful of that. So what I'm going to do, what I want to do is I want to fasten these two fans together, because individually a mouse coffin could probably actually blow a bit more air than these things, whereas together they should get just enough volume through them. Not bothered about losing any more hair than I need to with the wind speed, just volume of air, so there's a nice volume of air, but at the same time I want to be able to adjust it, hence the reason for using this module and an Arduino. I could go another route, use PWM, use a 555 timer, transistor, and go down that route, which you never know. I may do another video on using a transistor and 555 timer and going along there, but we'll see how it goes. So first things first, the one thing I do need, and I can't see, is a pair of scissors. So we're going to have to, I'm afraid, do. Oh, you saw them before I did. So I was just going to put some cable ties through, fasten them off, wrap them around like that, and fasten them together. But then it occurred to me, if I do that, there's a good chance that we're going to get some vibration. So I thought, stick it, a double-sided tape, that's got a bit of foam on it. Just doesn't have to be a lot, just enough to absorb a bit of vibration. So get them together. There we go. And then we'll thread our cable tie through. So, a note on cheap cable ties. If you want to cut cable ties, there's a couple of things of note. If you cut them at an angle, you leave a really sharp edge. Whereas if you cut them flush, they tend to be okay. If you don't want them flush and you have trimmed them, please get a little bit of sandpaper, emery cloth, anything, and just take those sharp edges off. I used to be a mechanic in a previous life, and basically down the back of my finger there, I've still got the scar. Now that I've got a scar down the back of that finger, that is from 30 years ago. I put my hand down the side of in an engine compartment, and there was a sharp edge off a cable tie that cut the finger from the knuckle to there down to the bone. Since then, I always advise just to give them a little bit of a clean up, a trim. And don't need these two cables, but I do like the idea of the pass-through. But I don't want to go to those lengths. So all I'm going to do is break into the cables there, connect them together, and just leave me one. We'll just power them individually. I could sit that on there, and I could power them both together. Right, welcome back. So we've got it all put together now. We've got our main feeds to our motors out of the sides. At the front edge here, going from left to right as I look at it. On the left here, we've got our motor input power. Center, we've got 0 volts ground, if you like. And on the right of the block of three power units, that can be 5 volts in or out. That is unregulated. Do not put more than 5 volts on that rail. You're being warned. Back here, we've got a jumper. So this jumper what this helps you with, or does, should I say, is when you're using up to 12 volts. Up to 12 volts. That enables the regulator. The regulator will then regulate the up to 12 volts, so from between 5 and 12 volts, will regulate that to 5 volts and give you 5 volt out here. So you can actually power your device, your Arduino Uno, Nano, Micro, whatever device it is, as long as it's 5 volts, that will actually power it there. Moving across, we've got our jumper pins. So first one is called ENA. So that is enable channel A, this being channel A. Then we've got 1N1, 1N2, 1N3, 1N4. 1N1, 1N2 all go to the Arduino. I say all go to the Arduino, and these are the control of the motor, as are these. So these basically control the motor chip, the L298N, and using the PWM signal, pulse width modulation signal, they will determine how much current, how often it's the power switched on and off to power the motor. And it's worth bearing in note, some motors don't like PWM. So this could turn out to just be a howling mess. Because you'll soon know if your motor doesn't like PWM, because you'll hear a high-pitched whine, dogs will be running, bats will be flying around, and you'll be crying on the floor in minutes. Okay, it's not quite that bad, but if you don't like high-pitched noises, it's not what you want. So I'm going to, this can be used for both DC motors and for stepper motors. If you're using it for DC motors, you remove the jumpers of ENA and ENB. Remember, remove the jumpers of ENA, ENB. So now we've got our PWM signal, control, and we've got, so control motor A, we'll call this motor A. And then we've got control motor B and our PWM signal. So we can control these two motors independently, as in forward, reverse, speed up, speed down. So yeah, if you wanted to build a hovercraft or something like that, you could use this. Obviously not one that would carry you, but a mini hovercraft, yeah, you could do that with that. So you could control it. It would actually be quite a simple task, 2 or 3 of them, and you've got a hovercraft built. Simple as that. Okay, so I shall get the cabling set up. This unit came pre-soldered. What I might do, because I'm not happy with the way the pins are laid, as you can see there, I'm going to actually reflow that solder and straighten them up. Hi guys, here we are, we're ready to rock and roll. We've got our 2 enables, our 2 controllers, our Arduino. Next step is to cable this up. So there's many ways of doing it. I've found a sketch. I didn't write it all from scratch. There's no need to. It's already done. I'm not reinventing the wheel. This is not rocket science. This is not fire. This has been done ridiculous amount of times. Make life easier for yourself. Find the sketch, which I'll actually put a link below to this particular sketch that I'm going to use. And you can see how easy it is to put together. What I'm going to do is I'm going to flick over to another screen, and we'll probably talk about that as I cable up, put the wires into my Arduino, and then you can do this whenever you want. So as I'm going to show you now, I've actually made a few chip amendments to this little bit of code. This basically will right now just go all on, all off. So we've got our 2 function there, void all stop, switch everything off. And then the function below, switch everything on. We get to define the speed, so we can send the speed. And we're doing that down here. So we're setting the speed to 255. The speed can be anything from 0 to 255. 255 being 100%, 0 being 0%. So any value within there, and that will work. So what this will do is this will make sure it's everything switched off, which it should be. We will then set the speed to maximum for 10 seconds. So that's 10,000 milliseconds. And then we'll wait 10 seconds, and then we'll call all stop, and it will just keep on doing that. So it will stop for a second, start for 10 seconds, stop for a second, start for 10 seconds. You get the idea. Folks, as I'm sure you can see, we've had a slight change going on here. Yeah, I had an issue. It's something I didn't honestly expect, which is, I think, what bugging me up totally. Turns out these fans will not work in reverse. Also, you'll notice that I've now got a ground reference, which is something I omitted to mention earlier. So you must always, when you use an external power source, is ensure that the Arduino is referenced to the same ground. It needs to be done. I'll let you investigate why, give you something to do. But anyway, we're ready to rock and roll. So right now, as you can see, we've got our little LED there blinking. I think you can see that, which means that we've got the blink sketch on there, on that Arduino. I've lifted the fans off the desk a little bit. They're just sat here with pens under them, just to give it a bit of space. You can see our unit there is powered up. There's a light on. Let's see if I can zoom in a little bit for you to make that a bit more visible. Yeah, that's a little bit better, isn't it? Still can't see. Oh, you can't see the light. You just make out the LED there flashing. Okay, that's great. So what I'm going to do now is I'm going to flick over to the Arduino capture, and there we have it. So this is our sketch. All we're going to do now is going to make sure we've got our Arduino Uno selected, and it's connected to the correct COM port. So we're ready to go. You don't need to verify it. I will, and then we'll just hit upload, and I shall now scoot you straight over to the main one. And that tapping noise is the fan hitting the pen. There we go. Run for 10 seconds. Stop for a second. So, because you can't see that too well, I think what I shall do is I'm just going to change the Arduino sketch and increase the delay to 2000. Again, simply a case of verify, upload, which compiles, and that is now uploaded. So there we are, we have power on, off, yeah, works spot on. So that is at 255. So what we'll do now is I shall change over to the right area and we shall just slow it down and run these at 100. Remember, that's not 100%. That is a value between 0 and 255. And so we shall upload that and flick back to the main camera. That's the PWM wine. I hope you can hear that. It is really irritating. I can feel my teeth itching already. So we'll increase this to 200. I'm not going to flick back between the screens. You know what I'm doing. I'm changing the value of all on full to 200. There we go. The sketch is uploaded. It's a no-go. That will drive me nuts. And I'm sure that will drive anybody nuts. So basically, I'm going to put that back to full power. And we'll upload the sketch. You'll see it flashing there, the RxTX flash. And the sketch is uploaded. We have sounds again. Now there's something to note. We're putting 12 volts in. There's our meter. We actually only get 9 volts. Something I noticed earlier. There's a bit of hot glue stuck to that. Yeah, so as much as I would like to control these, or you do something like that, you guys control them outside, I can't. That kind of sucks. So there we go. That's that project. We've given it a try. It's making noise. Made a couple of schoolboy errors. Left-hand fan wasn't working while I was off camera, and I was assuming that there was a problem. These are all cheap Chinese things. I was assuming that it was these that were the problem. It wasn't. It was just that the fact that fans are cheap and Chinese, and the polarity was reversed. That's all it was. Don't forget, if you're using a module like this, any module where you're powering externally, always ground reference. Okay, just put the ground into your Arduino, and trust me, it might work, it might not. Without the ground, it might work, but you'll definitely get something odd happening. It won't work 100% as you expect it to happen. So just be careful. Hope you enjoyed this little project. This little see if it'll do it. We've proven it doesn't work, or it doesn't work how I want it. I'll do a bit of investigation. If I can figure out a way of doing it, or find somebody that tells me how to do it better so that we don't get that whine, I shall extend this video a little bit. But if this is the end of the video, I couldn't find anything. Thank you. Take care. Hope to see you again soon. If you don't mind, subscribe, like the video so that I know if I'm doing the right thing or not. Yeah, and take care, guys. Well, as promised, I found out that it is possible to eliminate the whine. The whine is caused by the frequency at which the signal is switching. So it's within the audible range. You can change it to somewhere like 25 megahertz, I think it was. Kilohertz, sorry. Apologies, kilohertz. But that is way beyond the scope of me doing a video here. But I just thought I'd say, yes, it can be done. Will I do it? Probably not, because in reality, 12 volts in there, and that's a nice breeze, and it's quite quiet, so I'll just stick with that. Thank you again. Take care.